For those of you who have visited the website, any of you have found something funny posted to the recorded lecture website, to the folder? Or none of you have visited yet? In the course folder, there's one course material from me. Okay, inside there, then another one folder is the recorded lecture I created. I set a direct link there, right? Any of you visited there? Okay. Yesterday I visited the doctor again. So he strongly advised me not to speak for a few days at all. Okay, but it's impossible. All right. So in fact, last night I have already prepared and posted last year the same lecture for today and tomorrow onto the website. Have already posted there onto my folder, recorded lecture, the one I set up on. It's not the one set up by the system, it's the one set up by me, myself. Okay, so after that lecture, please visit that website. Yeah, this is he strongly advised me to not to talk anymore. Yeah. So after that, I said I still have to talk. Then he just write down the MC 2 days. Yeah. So you can see from this. Okay, I have one suggestion is here. We used last year the 2 recorded lecture, lecture 9 and lecture 10. And for today, I'll make the best use of it for my first hour of trying to speak. I will discuss a tutorial question. Tutorial 4, so it will be recorded also, since it's here. Yeah. So later we will not have tutorial session, because it is even very difficult for me to raise a voice in a small class. I think this is more productive. And I posted the website, so we will not have physical lecture for today and tomorrow, and we will not have physical tutorial for today and tomorrow as well. So we will replace it all by recorded. Is it okay? Any objection? Oh, okay. Which one is that? Sorry. Okay. This tutorial 4 is on the class diagram techniques. The first question is on drawing a class diagram. Okay, before we go into some details, I would like to highlight a few points. For such question for exam or quiz, it will be a precise one. And one important point I would like to highlight to you is, please try to model the mean point. Mean point, do not miss any mean point. Things like if there is a clear association, if there is a clear aggregation or generalization there, must include them. These are the major points. Try to look at the big picture first before you look at the small one. That is the way to deal with such questions. Okay, this question is on drawing a class diagram to model the following. Structural properties in the order processing system in the company. So this, anyway, class diagram is to model structural property. The structure of information and the structure of associated tasks. Okay, here customer place order. Okay, things like such things are very clear. There is from the information given, there is a clear association there. Okay. Customer place order. And place, okay, place is an interaction between customer and order with the company. Since the system is for the company, so this one is not specific to this case, to purchase product. So this to purchase, order is here say that the order is to purchase product. Okay, this part indicates the order to purchase product. And sold by the company. Again, the company is, all these things is within a company. So within a company, so company, you do not have to model. It does not add in any specific detail. A customer may have none or multiple order placed. They may have one, they may have multiple. Each order is always placed by one customer, and it has. So you have to comprehend the case in such a way. Each order is always purchased by one customer, and it may have single or multiple order items. So here I give you, you have to capture all these things. These are the important things. And each item is purchased one product. An order item could be fully fulfilled, partially could be. It means that it can be a few types: fully fulfilled, partially fulfilled, or totally unfulfilled. Periodically, an invoice is raised to bill the customer. Invoice are to bill the customers for the order items. Okay, so this is the, so customer place order, very clear. And from the information given, order has many items. Okay, order is to purchase many items. Okay, even whether here you say yes or you say here has or purchase. Actually, in fact, purchase will be more precise. Then, all the items are to purchase product. So in general, order is to purchase. Sorry. My mind not working. Order has many order items. This is good. This is correct. Exactly correct. Order has many order items. And order purchase product, you see. Then order item classified into these few types. So all these are the main information given in the questions. And invoice is to purchase, invoice is to bill fully fulfilled items. That is in the last part of the paragraph. So anything that either one, those multiplicity like 0 to many, or 1 to many, or 0 to 1, or exactly 1, if the case does not explicitly state it, then it is okay for you to put either 0 to many or 1 to many. Okay? Or the other case is also okay for you to put it as 0 to 1 or 1 if the question does not explicitly state that. Okay? So that's one point. Okay, now we go to the second question. Second question is diagnostics test. That means it's to test you on the understanding of the basic overall concept. If you have a clear understanding, you will find this question very simple. So this is a class diagram given, and there is altogether 10 sentences given. Okay, some parts are quite simple, quite straightforward. Some of the sentences are quite straightforward. Some you need a little bit more understanding. Here you can, in R1, each C1 object is associated with at most one C2 object. Here say that in this R1, each C1 object is associated at least one C2 object. Okay? No. In R1, each C1 object is associated with at most one C2 object. Each C1 object is associated with at most one C2 object. That is exactly the meaning. That is exactly the meaning of multiplicity here, right? Multiplicity here means when you interpret the meaning of multiplicity here, always reference to each instant of class at the other side. That means each C1 instant is associated with 0 to 1 C2 instant. That is exactly what. That is exactly the meaning of multiplicity. So definitely it's correct. So this question give you a class diagram and give you 10 sentences, ask you to check each of them to see whether it is correct or wrong, and give your reason. Okay, so it's because of multiplicity. It's very clear. In R1, different C1 instances may associate to the same C2 instance. Different C1 instances may associate with the same C2 instance. Okay, so you refer to the multiplicity here, right? Multiplicity here is 0 to many. 0 to many means each instant here is associated with 0 to many. Can be 0, can be 2, can be 3, can be 4, can be many. So surely, so this is definitely correct. Different C1 instances may associate with the same C2 instance because each C2 is associated to 0 to many. Some could be 5. So if they associate to 5, that means that particular C2 will associate with CX1, CX2, CX3, CX4, CX5. Associate 5 different C1 instances. So how can that? That is definitely true. So it's due to the multiplicity here. Here. This one. Okay, here say that each instant of R1 associate a C1 object with a C2 object. Okay, every instant of R1 definitely associate a C1 object with a C2 object. R1 is an association between two classes as a binary association. So every instant of an association definitely associate one object from each associated class. So in other words, a binary association definitely associate two objects, one from each class. So that means every instance R1 definitely associate an instance from C1 and an instance of C2. That is very clear. That is because R1 is an associate these two classes. Some instance of F1 may not be part of any D1 instance. Some instance of part of F1, some instance of F1 may not be part of any D1 instance. Okay, so you look at this multiplicity. 1 is here. That means each instance of F1 is definitely a part of one D1 is exactly 1. So there is no case that an instance of F1 will not be part of any D1 instance, because due to the multiplicity here. Okay, here we come to a each instance of E1 is an instance of D2. Each instance of E1 is an instance of D2. Okay, that is definitely correct, because every instance of a subclass is definitely an instance of the superclass. Every instance of a subclass is definitely an instance of the superclass. Then we come to an equation. It says that each instance of D2 is an instance of E1 or E2. The other way around, an instance of superclass is an instance of one of the subclasses. Okay? The other way around is not always true. In your lecture note, I have given you an example. NTU student is the superclass, and EE student and SC student are two subclasses. Okay, so in that case, an NTU student may not be a EE student and also not a SC student also. So it could be an NBS student. So an instance of the superclass may not be an instance of any of the subclasses. That is the meaning of generalizations. Okay, here saying that we can add notation to multiplicity notations. To the generalization between multiplicity notation does not make sense to generalization. Generalization is a way to specify classification. Specify the classification, classify a general type into subtype. So there is no meaning for you to use multiplicity. It does not, multiplicity generalization does not relate different objects. Okay, I have to consider the time. I will spend more time on the last questions. Yeah. So these three questions, if you understand this, the last questions, it should be very easy for you to understand statement number 8, number 9, and number 10. So in order to give more time to the last question, I will just give a short explanation on for the next three sentences. At a particular point, R3 may have only one instance. Okay, it says that at a particular point in time, R3 may have just one instance. That is not possible. If R3 have an instance, that means this particular instance will associate three objects, one from here, one from here, and one from here. Right? Then, so this is given. This is given. But with this given fact, there is a G1 instant and there is a G2 instant. That means there is a combination of G1, G2 instants. There is a combination there. Okay? So, but according to this diagram, here 2 to many. So this particular combination, this particular given combination must associate with at least 2 G3 instances. Associate with at least 2 G3 instances, what does that mean? Associate with at least 2 G3 instances, that means if we represent it mathematically, that means G3, we have at least 2 tuple, at least 2 tuple. Each tuple is for 1 instant, okay? Because in order to associate 1 instant, you have to be, mathematically, you have to be in 1 tuple. So that means the number of instances R3, it has to be more than 2. It cannot be 1. From 1, you can reduce it to 2. That means it's a contradiction. That means the given fact is wrong. If anything given is wrong, that means if from the things, if given something and ask you to derive something, okay? If the given fact is wrong, then that means the other way around is true. So that means on one hand you can argue, you can give your reason in this way. On the other hand, you can also prove mathematically by contradiction. Okay, that is about 8, 9. Say G2 and G3 have some instances. It's not necessary for R3 instances. Okay? It says that when G2 and G3 have some instances, G2 and G3 have some instances, then it's not necessary for R3 to have any instances. Okay, again, that means it says that when G2 and G3 both have some instances, if we represent it mathematically, it means the set of R3 instances, the set of R3 instances is an empty set. No instances mean empty set. Okay? So, but that again contradicts to the multiplicity here. If G2 and G3 both have some instances, that means there is a combination of G2 and G3. And according to this diagram, each combination of G2 and G3 must associate at least 1 G1 instance. That means associate at least 1 G1 instance. Mathematically means that in your set of R3 instances, at least must have 1 tuple. So there's no case that for R3 to have no instances when G2 and G3 both have some instances. Okay, the last one, the sentence number 10, actually, in fact, is nothing to do with the multiplicity. It's on the generalization. But I think this one is quite easy. By looking at the it says that the total number of subclasses, if you add up the total number of subclasses, it may not. Okay, I put it says that the total number of superclass instances could be greater than the sum of number of instances of subclasses. That is definitely true. Okay, you look at the case. NTU student is a superclass, AAA student, SE student. So the number of NTU student is definitely more than the number of AAA student plus the number of SE student. Okay, question 3, I will just want to say a few words. So again, is to give more time to question 4. This is a class diagram, and they ask you to interpret this class diagram. Given a class diagram, ask you to interpret the class diagram according to the basic concept. the definition of the basic concept. Okay, mainly you can mainly you can interpret it from the multiplicity, okay? From the multiplicity. So you can just interpret from every multiplicity of each association, aggregations, but there's no aggregation here. And you interpret the generalization also that way. That you will get the complete meaning, okay? So here something like each department, from here you can interpret that. Each project, okay, is managed by what exactly? By one department. Each project is managed by one department. So you interpret in such a way. And for this part, after my interpretation, in my answer, the answer you are going to see, the interpretation in the sample answer, I have rephrased it. After the interpretation, I have rephrased it. But for quiz and exam, you need not to rephrase it. If you don't rephrase it, it's perfectly okay. That means for this part of the class diagram, if you interpret in 3 sentences, for each multiplicity, then it's okay. That means each supplier and project, each combination of supplier and project, okay, is related to at most 2 parts, 2 ship association. That is a raw interpretation from the meaning. You can interpret in such a way and have 3 sentences. The other one, 3 sentences mean one from here, one from here, one from here. Each combination of supplier and project is related to at most 2 parts to the ship association. There's a raw interpretation. Okay, the rest I'll leave it to you. Okay, I will explain this question in more detail. Once you are clear about this question, I think you should be able to. I think you should have a clear understanding of the multiplicity concept. So this question is in this class diagram 3. The number of instances of G1, G2, G Mn, Pq. Okay, so all the instances are given Mn, Pq in this class diagram. So for conveniences, we write it down. This given that G1 G1 have M instances, G2 have N instances, G3 have P instances, G4 have Q instances. So these are the given facts. And this MNPQ all greater than 0. And this question asks you to prove that and prove these 2 inequality. Okay? From all these given facts and the class diagram, and the class diagram mainly from the multiplicity, asks you to prove these 2 inequality. Okay, the proof is here. The first one, given with the number of instances of G1, G2, G3, G4, Mn, Pq, okay, we can compute the total number of R3 R instances. Given with all these instances, and from one of the multiplicity, we can compute the exact number of instances of R. From which one? From here, from the multiplicity at G1N. Why? Because the multiplicity here Multiplicity always reference to other classes, right? So for the case of ternary and above, it means refer to each combination of instances from associated classes. So the multiplicity 1 here means that each combination of always reference to other classes first. That means each combination of G2, G3, G4 associate exactly one G1. Each combination of G2, G3, G4 instances associate exactly one G1 instance. Okay? So if we represent all the R instances as a set of 4-element tuple in this case, okay? So that means every element in the tuple will every element in the set will have 4. It's a tuple with 4 objects, 1 from each class. So if you represent mathematically in this case, every instant R, okay, is a 4-element tuple, okay, 1 from each class. So here say that every combination of G2, G3, G4 associate exactly one G1 instance means that every combination is in exactly one tuple with G1. Every combination G2, G3, G4. As far as there's a combination, then there should be a tuple. Then associate with a G1 instance. Okay, what does this mean? This means that there is a one-to-one correspondence between combination of G2, G3, G4 and R tuple and R instances. There's one-to-one correspondence. So from this we can conclude that total number of R instances is equal to total number of combination of G2, G3, G4 objects, because every combination must associate with exactly one G1. I mean every combination must participate in exactly one R instance. Okay? So that means there's a one-to-one correspondence. Since every combination participates in exactly one R instance, okay? So that means that there's a one-to-one correspondence between G2, G3, G4 instances and R instances. I show you a picture to illustrate that. That means every combination G2, G3, G4 is correspond to exactly is one R instance. It cannot correspond to 2 instances, exactly 1. So that means one-to-one correspondence. That means the total number combination must be exactly the same total number R instances. So from that we derive that the total number R instances is equal to the total number combination. That is NPQ is given. Okay, it's written down here. So we use this notation to represent the total number of R instances. So since the G2, G3, G4 combinations instances have a one-to-one correspondence with R instances, so they must have the same instances. They must have the same number of instances. So from that, we deduce that total number of R instances is equal to total number of combinations. So that is NPQ. Because over here, we have G2 have this amount of instances, G3, P, so the total number of combinations is NPQ. So from this, we derive the first equality. And likewise, from the multiplicity here and here, you can deduce some more relationship. So the total number of R instances is equal to NPQ, is written down here. And now we proceed to the second one. Here is 2 to many. Okay? So according to the definition of multiplicity, means that every combination of G1, G3, G4 always reference to other classes. So every combination of G1, G3, and G4 always associate with 2 or more. Okay, now what kind of correspondence between combination and R instances? This is the kind of correspondence now. It's no longer 1-to-1. This is the kind of correspondence now. Every combination of G1, G3, and G4, okay, correspond to at least 2 because associate with 2 or more. As far as there's a combination, the combination must participate in at least 2 R instances. Here and here, something like that, okay? 2 or more. Okay. So the second one also associates every combination is correspond to at least 2 R instances. So now since we have this multiply kind of combination, so from here, what can we reduce? We can reduce that the total number of combination, right? Here have less, right? Here have less, here have more, right? You can see that here have more. How many? Any relationship. Here have at least, here have at least 2 times the total number of combination, right? Because each combination must be in at least 2. So that means this side is R instances. That means total number of R instances is greater or equal to at least 2 times the total number of combination. Here, the total number of combination. Because every one of them will multiply at least 2 times. So we have this derivation. Since the multiplicity, looking at the multiplicity this side, now we reduce that. Okay, the total number of R instances must be equal to. We use the same notation to represent the total number of instances. Okay, R put in close within 2 vertical bar, greater or equal to 2 NPQ. That's NPQ is the total number of combinations. Now we substitute. Since earlier we already calculate this is the exact number of R instances. Total number of R instances equal NPQ. So we substitute NPQ into here. We get this. We get this combined inequality. We get this. Okay, now we come to the last relationship we can derive. That's looking at here. Okay, looking at here, what kind of correspondence between R instances and combination we can reduce? What kind of correspondence? Okay, here you can see that every combination associated with either 1 or none. Some will associate 1, some may not associate any. So this is the correspondence now. G1, G2, G4. Now it's looking at this side, so it's every combination of these 3 instances from these three classes, one from each. Okay, and some correspond to one R instance, some do not correspond to any R instance at all. You can see from here, some nothing here, no arrow drawn. Here again, the third one associate with what? The third one associate with one G3 instances. That means correspond to the R instance. Okay. And the next one does not correspond to any R instance, so empty. So now which side have more? Now, if comparing with the combination of G1, G2, and G4, the total number of R instances have less. You can see from here have less. Okay, there's a lot of hole here. So that means the total number of R instances is less than or equal to total number of combination here. But from the given fact, we can compute the total number of instances here. That is M and Q. So the total number of R instances is less than or equal to M and Q. Is this Nash inequality? And again, we substitute the first one into here, because in the first part we have computed the total number of R instances, that is MPQ. So we substitute MPQ here, we get this. Okay? Then we combine these two Then we combine these two together, we get this one. Then after that, you do some simple cancellation, because all the M and PQ are all greater than 0. Then you get what you need to prove. That's the way to go about it. And okay, another point I would like to highlight is how many instances, how many objects R3? Every instance R3 have how many associate, how many objects? Every instance R3 associate how many objects? Just now earlier we have one sentence on a binary association. Now this is a ternary association. So every instance of R3 associate how many objects? R3 is here. Since we still have few minutes, each instance R3 associate with how many objects? Any answer? I'll be disappointed if I cannot get any answer. Every instant R3, that means if you represent mathematically every tuple to represent an R3 instance have how many objects there? Any more answer? Come on. Can you speak? Can you speak loud? Yeah, 3, exactly 3. There's no case that every instant R3 associate 2 objects or more than 3 objects. R3 is a ternary association. Okay, associate 3 classes. So that means every R3 instance associate 3 objects, 1 from each class, 1 from G1, 1 from G2, 1 from G3. Always the case. So the number of objects associated in an association instance is not affected by the multiplicity. You won't be affected by multiplicity. Okay? It depends on how many associated class. Okay, now I say a few words on quiz. The quiz will be MCQ. Anyway, this will be recorded. The quiz will be kind of MCQ, okay, and short question. Give a very small case, ask you to maybe draw a class diagram or draw a small use case diagram. Okay, that kind of questions. Okay, or draw an ER diagram. And there will be some question to test you on the understanding of the basic concept. Okay. Things like the question that I've just posted. Okay, so it will be 35 minutes, and since quiz will be conducted next week, so tutorial 5 solution will be posted by the end of this week also. Although tutorial 5 will be conducted next week, I will post it by the end of this week.